Machine learning encompasses two primary techniques, supervised and unsupervised learning. Each serves distinct purposes and scenarios. Supervised learning involves labeled data, guiding models to predict outcomes. Unsupervised learning, however, discovers patterns within unlabeled data. Understanding these methods is crucial for applying machine learning effectively in various fields. Supervised learning involves training models with labeled data, mapping inputs to outputs. It requires guidance, akin to a teacher-student dynamic. This method is essential for tasks like classification and regression, where the model learns to predict outcomes based on provided examples. Supervised learning tackles classification and regression tasks by training models on labeled data. For instance, it can identify fruits by learning from labeled examples, predicting outputs based on patterns. This method is essential for applications where precise output predictions are required, leveraging the model's ability to map inputs to outputs effectively. Unsupervised learning autonomously discovers patterns in unlabeled data, focusing on data structure and patterns without supervision. Unlike supervised learning, it doesn't rely on labeled data sets. This approach is crucial for clustering and association tasks, where models self-train to identify inherent patterns, offering insights into data organization and relationships. Unsupervised learning tackles clustering and association challenges. For instance, it groups fruits by similar features without labels, allowing models to self-train and identify patterns. This approach is crucial for discovering hidden structures in data, enhancing our understanding of complex datasets. Supervised learning relies on feedback to enhance accuracy, predicting outcomes based on labeled data. In contrast, unsupervised learning operates without feedback, uncovering hidden patterns within unlabeled data. While supervised models focus on prediction, unsupervised models excel in pattern discovery, each serving distinct purposes in machine learning applications. Supervised learning focuses on making accurate predictions using known outputs, requiring labeled data. In contrast, unsupervised learning seeks to uncover insights from unknown data, needing only input data. The choice between these methods depends on the availability of labeled data and the specific goals of the analysis. Supervised learning employs algorithms like linear regression and decision trees, focusing on labeled data for precise predictions. In contrast, unsupervised learning uses clustering and KNN to uncover patterns in unlabeled data. The choice of algorithm hinges on the dataset's nature and the specific problem at hand. Supervised learning, unlike true AI, relies on pre-training with labeled data, akin to a teacher-student model. Unsupervised learning, resembling AI, discovers patterns independently from unlabeled data. Choosing between them depends on dataset structure and specific problem requirements, highlighting the importance of understanding each method's unique applications. Understanding the differences between supervised and unsupervised learning is crucial for selecting the right approach. Both methods are indispensable in machine learning, each serving unique purposes. Mastery of these techniques empowers effective problem-solving and innovation in diverse applications.